Hi, my name's Kevin and welcome back to Toy Trains 101. Today we're going to be installing a Blunami decoder in an American Models high rail S-scale E8. So the reason that I started doing these conversions on my modern S-gauge equipment is that the modern S-gauge locomotives, particularly from manufacturers like American Models and S-Helper, they look really good, but the electronics in them leave a lot to be desired as far as sounds and things like that. So I thought that I could upgrade them and make them into a much nicer model with a lot of the more modern features. And as a side note, you can get locomotives from the factory with similar features from American Flyer by Lionel, but then those features still aren't as nice as what you get with Blunami. And for those locomotives from Lionel, you're going to pay anywhere from $1,500 to $2,500 for it, whereas with this, I did an American Models Northern, and all in with the cost of the locomotive and the decoder, I was at about $360, so significant savings there. We're going to show you all the tools and materials needed to do that. We need the decoder, and I like to put a current keeper in them as well, just to help them get over switches and things like that. We need a speaker. We're going to need a screwdriver, wire strippers, some small tweezers, heat shrink tubing, a soldering iron, double-sided tape, solder of course, and we might need some other tools along the way. Sometimes you never know once you get into these engines, you end up needing things that you weren't aware of from the start, but I'll try to mention that as best as I can as we go along here. So let's get started. So we're here at the workbench now. This is our locomotive that we're going to be working on today. This is Southern Pacific number 6018 E8. Now, for those that don't know the history of the 6018, this was the only E8 that the Southern Pacific ever owned. It was part of a canceled order for E8s that the SP placed. It was the only engine that was delivered off of that order. The order was placed right after World War II, and EMD was having all kinds of supply issues and trouble getting their units out at that time. And the SP got tired of waiting, so they canceled the order for E8s and went to Alco and ordered a fleet of PAs instead. So this was the only E8 that was delivered off of that order. All the other E units that the SP had were either E7s or E9s. So that's kind of interesting. So now we're going to take this locomotive apart. I have it in my cradle here. And it's just 4 screws that hold the shell on. And then after that we have to fiddle with the shell a little bit to get it off. Oh, let me... Here, I use my little magnetic bowl to keep the screws in so we don't lose anything. All right. Now, oh, there it is. So our first step is basically to remove everything on this engine, on this chassis that's not the motor and drivetrain, because we don't need any of it. The Blunami decoder has everything that we need built into it. So all this stuff is now trash. Now I have a speaker that I want to use in this install, and I'm hoping that it fits under this drive shaft here. I think it will, but if it doesn't, I may need to reuse these speakers that are in here. So I've removed the factory speakers out of this locomotive, and I'd like to use this little cube speaker here. These are my favorite speakers to use on my conversions because they have really good range. And I found that this speaker fits just under the drive shaft here with just a little bit of clearance under there. So I'm not going to be able to use the double-sided foam tape that I would usually use to secure the speaker. So to secure the speaker, what I'm going to do is remove this truck and this drive shaft so that I can press this speaker down onto some glue here and secure it that way. So I've got my 3/8 wrench here, and I'm going to remove this truck. It has a nylock nut that holds the truck on. Now we can remove this drive shaft. Ignore the noise, my gardener's here taking care of the yard today. Now we have access to where I'm going to mount the speaker here on the chassis. So what I'm going to do is put a dab of model glue on all four corners of the speaker and then just place it here over the hole where the old speaker was. Alright, so now our glue is dry. We're going to put the truck back on and move on to the decoder. So this is a Soudtraxx Blunami decoder. This is the model BLU 2200. This is a 2 amp stall current decoder, which works perfect for any S-scale locomotive, because these don't pull that much current. I think when they're running, you have maybe half an amp. But this is a different kind of a decoder than what you might think of as a regular DCC decoder, in that it has Bluetooth capability, which means that I can run this locomotive from my phone without the need for any kind of a DCC system or anything like that, which allows me to run this locomotive on the same tracks with my post-war American Flyer locomotives without issue. I've test fit the shell back on top of the chassis here. We've determined that the decoder will fit on top of the motor. We were testing the clearances here for the shell because it'd be bad to do everything and then try to put the shell on and find out it doesn't fit. So now I'll stick the decoder on. We have the decoder stuck to the top of the motor now with double-sided foam tape, but I'm going to take this piece of black duct tape and wrap it around the top just as a little bit of extra protection in here to make sure that this thing really doesn't move. And we're going to see some more of this black duct tape here in a minute. So now we're looking at the shell for this locomotive, and I've done some work on the lighting on this off camera. I said we were going to see some more of this black duct tape. Well, here it is. The way this engine was originally set up, it only had one headlight that was functional, and I wanted to make the Mars light and the number boards functional as well, so I've wired them up with LEDs here, and I'm using this black duct tape to prevent light leaks between the different lights. And then back here, you see the black duct tape running along the top of the shell here. Well, that's because the exhaust stacks and the cooling fans were all open into the shell, so you would have had light leaking out the top of the fans. So I've covered the back of the fans up with the tape as well. And I also decided that I'm going to put a cab light in this engine, so we'll set that up as well. And I have these 2-pin JST connectors here that I've wired my lights to, so that if I ever want to take the shell off, I can just unplug the shell and it'll come right off without having to do anything to the wiring or worry about breaking it. So what I have here is a roll of warm white LED strip lights like you might use for an under counter light or something like that. And these lights are designed so that you can cut them to any length that you want, and then they have two pads where you can solder your wires to. So I'm going to use one of these for the cab light and just mount it up inside the cab. They have adhesive tape on the back of them, so it makes it really easy. So all I have to do is take one off and cut it. So I've taped my LED to the workbench now, and I'm going to solder this JST connector to it. I'm actually going to come over here and tin these wires first so that I don't have to apply a whole lot of heat to the LED itself, because the adhesive on the back will actually burn. When I'm using these strip lights like this, I like to cover the wire connections when I'm done soldering with liquid electrical tape, just in case the adhesive on this ever fails or anything and it falls down inside there, so it won't short out against anything. And this stuff can be kind of messy. So we're getting ready to start wiring our decoder up here. We're going to be using this wiring diagram that came with the decoder. Now, all of this stuff on here doesn't necessarily apply to every engine that you're going to do. For example, this locomotive doesn't have a backup light, so we're going to skip that. And then we have the different function outputs for the different lighting effects that we're going to use, and we're going to talk about that here a little bit later. So it's just a matter of making the wiring connections here on the locomotive. So our first step here is we need to get power to the decoder. Now this presents a bit of an issue when you're talking about toy trains, or S-gauge in this case, S-scale, because we use AC track power. And the decoder is designed to run on DC. So what we need is a bridge rectifier, and what this is going to do is take our AC track power and turn it into DC. Now we also take a capacitor and we wire it across the negative and positive terminals on the bridge rectifier to filter the DC current coming out of it so that we get a cleaner current going to our decoder. So here we have our bridge rectifier, and we're looking at the top of it right now, and we see that we have all these different symbols here. These two legs that have this squiggly line symbol on them is where our AC current comes in from the track. Now, because it's AC current, it doesn't have a polarity, so it doesn't matter which rail goes to which side of this. Coming off of the bridge rectifier going to the decoder, we have a positive and we have a negative. Now that part's really important. You don't want to mix the AC and the DC up here because you can fry your decoder. So we're going to set up our bridge rectifier circuit now. I have a 1000 microfarad capacitor here that we're going to use to filter our current. And I'm going to wire, or solder rather, the negative side of the capacitor, that's the side with this white stripe on it here, to the negative side on the bridge rectifier. So I'm putting my flux on here for our solder connection. So now we have our capacitor soldered to our bridge rectifier here, the next step is to solder the power leads coming off of this to the decoder. On the wiring diagram, they have a right rail and a left rail, and for our purposes, the red wire is positive, that's the right rail, and the black wire for the left rail is negative. So we're going to go ahead and solder the red wire to the positive side of the bridge rectifier here. We'll cut it short. And we will solder the black wire to the negative side of the bridge rectifier. So the next step is we need to get power into our bridge rectifier here. And we have our power coming off of the right rail on this truck and the right rail on this truck. So what I'm going to do is I'm going to solder these two wires together, and then I'm going to solder them to this leg on the bridge rectifier. Like I said, there's no polarity on the AC side, so it doesn't matter which of the two AC legs that you use. You just want to make sure that you don't mix up the right rail and left rail wires and accidentally solder them together, because then you will have a problem. And on these AC models, the wires for the rails aren't color-coded, so you just have to trace out the wires and see where they go. So we're going to repeat this process for the other rail, and I'm just going to solder it onto the other AC leg of the bridge rectifier here. So now we're going to wire the motor to the decoder. The orange wire is motor positive and the gray wire is motor negative. This particular motor isn't labeled as to which one is positive and which is negative, but if we end up getting this wrong, we can always reverse the polarity in the decoder once we get it installed. We don't have to redo it. So we're going to go with the top as positive, because that seems to be the pretty standard way. So now we're going to start wiring in the lighting functions. So what you're going to see is me wiring JST connectors to the lighting outputs on this decoder, since I have the JST connectors already connected to the lights on the shell. And the blue wire coming off of the decoder here is the function common, and it's a positive common, so all the positive connections for the lights come back to this blue wire, and the negative connections go to the various other colored wires here that control each of our functions. So now I've soldered all my connections, and while I was soldering, I put pieces of heat shrink tubing on the wires to protect the connections. So now I'm going to come in here with my heat gun and shrink all the heat shrink down. So we got the whole engine together now, wired anyway, and I realized that I forgot to install the current keeper, which what the current keeper is a bank of capacitors that keeps the decoder running and thus the engine running, going over dirty track and switches and things like that. It's really easy to install. All we have to do is plug it in to this little port here on the back of the decoder. Now I did have to cut some of this shrink wrap from around the decoder to access the plug. From the factory they come covered up there. So we're going to install this now with some of our double-sided tape. Okay, so now we're ready to bench test our locomotive here. I'm going to apply some power to the track. We hear our engine starting. Now I'm connected to the engine. Let's test everything. There's our horn, bell. Let's test the headlight. Okay, that's on. We'll go FX3 on. FX4. That's the number boards, they're on. And FX5 is the cab light, it's on. So that looks like everything works. Now, I'm going to go into this engine and get the sound set up right for this particular locomotive. So we'll go to main sounds, and it has it now as a 567. Well, we want dual 567s because this is an E unit. And we're going to change this horn to the Nathan M5. And we're going to turn that volume down a little bit. Okay. Now we'll set up our lights here. I want FX3 as an LED and as gyro light. And I'm going to set FX4 to LED, and I want it as on-off brightness 2. FX5 LED and on-off brightness 1. And that's about the basic setup that we need to do for this locomotive. Now we just need to dress everything up here with the wiring and give it a test on the layout. Alright, so we've got the engine back together now. We're going to give it a little test on the layout here to make sure everything works. We're going to start with the cab light. That works. Okay. Now we'll do the number boards. Okay, they work. How about the Mars light? Okay, that works too. Now the headlight. Alright, it looks like everything's working. But because we are not wanting to have our crew with no night vision, we're going to go ahead and turn that cab light off. One of the real advantages you get with this Blunami system is the slow speed control of the motor on these locomotives. They're capable of so much more than what they do with their factory control systems installed. Well, I hope you've enjoyed this look at what is possible with S-Gauge and Blunami. And it really applies to all toy trains, because everything that we did in this video today could also be applied to 3-rail O-Gauge locomotives. So, again, hope you enjoyed it, and thank you for watching.